Hello there, this is Ms. Nakayama. Today is 9.1, Properties of Radicals, Day 2, but I think it's easier to refer to as 9.1b, Dividing Radicals. Probably should have written that up there. That's how it is in Delta Math. It's the second day, easier to identify as B. So to review real quickly, we've been talking about radicals. We have an index N, and that's the wrong color. A radical with an index of n is in simplest form when three conditions are met. No radicands have perfect nth powers other than 1. We did this example yesterday. No radicands contain fractions. We did A, B, and C yesterday, and no radicals appear in the denominator. Okay, and we did A and B. And B, as I said to you yesterday, is what we're going to concentrate on today, and that is the quotient property of square roots. Yesterday we talked about the product property of square roots. So, and really we talked about this yesterday, y'all. When you had a product, we could have a product underneath, we could keep it together, we could break it apart. Whichever one of these two is easier for you to work is what you ought to do. So that's what we're going to concentrate on today in all of our examples. Okay, now these first group, when the denominator of a radicand is a perfect square, okay, it's easier to go ahead and simplify it. However, I'm going to tell you always, if I can simplify what's underneath here, then I'm going to do that first. So I can't simplify 11 over 49, but 49, the square root of 11 over 49 is the same thing as the square root of 11 over the square root of 49, and the square root of 49 is a perfect square. 49 is a perfect square, so the square root of 49 is 7, so this becomes the square root of 11 over 7. Number 2 is the square root of 25 over b, square root of b to the 4th. The square root of 25 is 5. The square root of b to the 4th is b squared, so it's 5 over b squared. I just took each one and took the square root of it and put it there. Number 3, negative square root of 21 over 81. 81 is a perfect square, so, and I know that 21 isn't, so even though I could simplify those, I need the radical to not be in the bottom. So this is easiest to go ahead and just separate them and think of it as the negative square root of 21 over the square root of 81, which is going to be the square root of 21 over 9, not forgetting that negative. All right, number 4 kind of brings in what we did yesterday, so I'm going to separate it, but I'm sorry, number 4, I was jumping to number 3. Number 4, we have square root of 25p to the 3rd over q squared. So remember what we did yesterday. We wrote that p to the 3rd as p squared p. Okay, we've just separated it. So on the top, it's going to be 5p square roots of p over q on the bottom. So my square root of 25, square root of 25 is 5, square root of p squared is p, and that p has to stay underneath the radical. Square root of q squared is q. Number 5, on the top, I'm going to have square root, it's the square root of 75 over 16t squared. So on the top, that's going to be the square root of 25 times 3, and the bottom is going to be the same square root of 16t squared. So on the top, 25 is my perfect square, so that's going to be 5 square roots of 3 on top and 4t on the bottom. I'm just taking each square root separately. Square root of 13 over 64, square root of 13 over 8, square root of 64, which is the square root of 13 over 8. Now this one I chose to show you. I didn't do it on number 3, but I did it on number 7 because I knew that 144 goes into 9 evenly, and it goes in 16 times. You might not know that, but that's the square root of 4. So if you didn't, you would end up with the square root of 12 over, you would end up, this could also be done, y'all, as 12 over 3, and then you reduce it and get to 4. So whichever one is easier for you, okay? Number 8, square root of 49. I'm not going to keep writing it, y'all. You know that this right here can be broken up to look like that. You don't have to write it that way if you understand that. So I'm just going to take the square root of 49 as 7. Square root of x to the 4th is x squared. All right, on number 9, I am going to write it separately because I'm going to separate the square root of 12 as the square root of 4 times 3 over the square root of 25. And the top is 2 square roots of 3, and the bottom is 5. Again, if you don't need that middle step, that's fine. But you do have to know how to do this without a calculator. So without a calculator that simplifies radicals. All right, number 10, I'm going to break up my 18 as the square root of 9 times 2. My bottom is still the square root of 49, so that's 3 square roots of 2 over 7. Number 11, square root of x squared over 100 is, of course, the square root of x squared over the square root of 100. A lot of talking, y'all. So what's the square root of x squared? X. What's the square root of 100? 10. So it's just x over 10. And this last one, I simplify it to x squared over 4 because I'm always about simplifying x squared over 4. Well, what's the square root of x squared? That's x. What's the square root of 4? That's 2. So this is x over 2. All right, in our next group, y'all, when the denominator of the radicand is not a perfect square, sometimes it's easier to divide or reduce first. So I've always kind of mentioned that I do this. Simplify the expression before doing the radical will save you some work. And here are some examples of that. So on number 13, if I, instead of dealing with the 11, if I simplify 88 over 11, that is the square root of 8. And the square root of 8 breaks up into 4 times 2, so this becomes 2 square roots of 2. Number 14, 12x cubed over 27x. Well, 12 and 27 have a common factor of 3, and the x is simplified to x squared on the top. So that's going to be the square root of 4x squared over 9. You can leave it in there if you can handle this. Okay, the bottom is a perfect square now when 27x was not a perfect square. So the square root of the bottom is 3, square root of the top is 2x. So it just becomes 2x over 3. 50 divided by 5 is 10. Square root of 10, I no longer have a fraction as the radicand or radical in the denominator. Number 16 is 2b up at the top. Example 2b. We talked about it yesterday. Number 17, 27 divided by 3 is 9. X squared over x is x squared. So this is the square root of 9x squared, which becomes 3x because the square root of 9 is 3. Square root of x squared is x. Number 18 simplifies to the square root of 12, and that is the square root of 4 times 3, so that is 2 root 3, 2 square roots of 3. Number 19 has that common 3 that we've talked about. If I take a 3 out of both of them and simplify my x's, then I'm going to get 25x to the 4th over 16, all underneath that radical. And then I just take the square root of each of that. So that's going to be 5x squared over 4. Okay? And, oopsie, come on. Oh, Pooh Bear. Sorry about that. Come on. There we go. Number 20. Number 20 says the square root of 24 over square root of 6. Okay, y'all, we've been separating them all along. You can bring them back together. That's just the square root of 4. And the square root of 4 is 2. Okay, now on number 21, when you do that, which is the way I would do this problem, I would say this is the square root of 1 over 8, 1 over the square root of 8. Okay, however you wish to think about it. But the process from there is what we're going to concentrate in the next group of examples. So I'm going to skip that one. 27 over 3, even though they're both under a radical, I can combine them back and divide 27 by 3 and get the square root of 9, which is 3. And this last one, how many times have we seen these numbers, y'all? I just did it in number 19. Those are the numbers. It's going to become 5/4. Okay, so last group here. Last group because, y'all, if you notice, it's blank in there because the stuff that comes after it on your worksheet, I know you talk about it plenty in Algebra 2, and so we're going to stop. And we're only going to do these last 5 examples. All right, so if the radicand, this is like example, this one up here that we talked about that I was going to tell you right here. Okay, this is what we're concentrating on now. What happens if I can't simplify these out? If I can't simplify them out, then I have to do a process called rationalizing the denominator. Okay, and what you do is you multiply the fraction by an appropriate form of 1. In other words, multiply both the numerator and denominator by a radical that's in the denominator. It doesn't have to specifically be the denominator. It just has to be one that eliminates the radical in the denominator. That's the last part here. So 2 over 5 doesn't simplify. So I'm going to multiply by the radical in the bottom. And this is where I talked about this yesterday, y'all. I just want to emphasize it again today. Okay, the square root of x times the square root of x is equal to x. All right, you could sit there and go, well, that's the square root of x squared, which is x. Okay, but that's just an extra step. So if I multiply this by square root of 5 over the square root of 5, on the top, they're both underneath the 2 and the 5, so that's the square root of 10. But on the bottom, square root of 5 times square root of 5 is 5. So I'm going to get the square root of 10 over 5. If you want to write the intermediate step of the square root of 25, go ahead. But I really think it's important for you to know the square root of 5 times square root of 5 is 5. So number 25. It's a little bit trickier, but it's kind of like the one that I just said we weren't going to do up top, number 21, because I have that 8 in the denominator. And this is where we come into the fact that you can multiply by anything, but remember, we need 2 of everything to bring it out of the radical. So when you think of 8, you know that 8, we've broken it up many times. 8 is 4 times 2. So 4 is a perfect square, but 2 is not. I need to see another 2 to be able to bring it out of the radical. I need to see another n to bring it out of the radical. So I'm going to extend my radical and just multiply underneath there by 2n over 2n. And when I do, okay, I have, probably should have written more, but anyway, I'm going to keep going like this. All right, I have on top the square root of 14n, because 7 times 2 is 14, and I got an n. But on the bottom, I have a 2 right there, I have a 2 right here, and 2 times 2 is 4, and n times n is going to end up. There's 2 n's, I get to pull one out. There's a 4 that has 2 2's in it, and there's 2 2's right here. So that becomes the square root of 14 over 4n. And if you wanted to see more of that, that's the square root of 14n, and over underneath it was the square root of 4 became a 2. I had 2 2's, I get 1 out. I had 2 n's, and I get 1 out. And that's how that becomes there. Probably should have shown you more. Okay, number 26. This one, there's nothing, I cannot simplify 7x in the bottom, so I'm just going to multiply top and bottom by the square root of 7x. On the top, I get the square root of 14x. What is the square root of 7x times the square root of 7x? Just like up here, y'all, it's 7x. So it's easy, multiply out the top and know that the bottom is what you just multiplied together. All right, 27, 3 over the square root of 3. I'm multiplying by the square root of 3 over the square root of 3, and that becomes 3 square roots of 3 over 3. But y'all, you got to remember to simplify, so this simplifies, and that leaves us with just the square root of 3. All right, now the last one, 8 over the square root of 10x. Again, there's nothing in here. There's not 2 factors of anything like we had back over here in 25. So this I'm going to multiply by the square root of 10x over the square root of 10x. And on the top, I'm going to get 8 square roots of 10x. And on the bottom, I'm going to get 10x. But just like I did on that last problem, I have a common factor of 2 in both of these. So this becomes 4 square roots of 10x over 5. And that is all I have for dividing radicals. Thank you so much for watching, and y'all have a great day.